All right. Welcome to my live stream. First, I'm gonna check some settings and the audio. So just hold on. See how it is. Okay, test 1, 2, 3. Okay, I just started the music. It could be a little bit louder actually. There is a small delay. All right. Let me know if it's all right or not. Terminal and everything, okay. Maybe the audio is a little bit too quiet. Maybe just a little bit. Yeah, I'm just listening to the audio on my phone. See if it's okay. Okay. Yeah, I think this is fine because I don't want it to be too loud. Because I don't want my voice to be hard to hear. Okay. My mic could be a little bit louder though. Okay, I think we're set. Alright. I hope so, because I'll be switching to my main headphones now. I'll keep an eye on the chat as well. Alright. So where was I? So last time I finished, I think, the previous section of basics. So this, I don't know what that is. Yet, I mean, I've seen it before actually. So I know what that is. Okay. Also, I am very happy because there is an interesting UFC fight happening later today. Nate Diaz versus Tony Ferguson. And that's going to be very exciting. I can't wait to see it. And I don't have a favorite, because I like both of them. Both are legends to the sport. Right. So last time, get basics. I think last time we finished that part, which had a lot of reading to it. Yeah. Yeah, we've done that. Also, where's my notepad? Here. Move that. Not notepad. I meant my Libre office writer. So I made some small notes there as well. With that said, I'm gonna take a look at Git and basics, which I already have open here. And just FYI, I am running a virtual machine inside my Windows 10 OS. So what that means, I have my main laptop, which is running Windows 10 OS, and now I have a virtual machine inside it. So you download VirtualBox, and then you have to download a Ubuntu or Xubuntu, in this case Linux OS. You install it and you have a computer inside of a computer, which is pretty fun. Alright, Git basics. In this lesson, we will cover common Git commands used to manage your projects and to upload your work onto GitHub. We refer to these commands as the basic Git workflow. Hold on. Let me just get this going. Much better. Easier on the eyes. And so you can see as well. We refer to these commands as the basic Git workflow. When you are using Git, these are the commands that you'll use 70-80% of the time. So if you can get these down, you'll be more than halfway done mastering Git. Lesson overview. Alright, so this is Git basics. Common Git commands used to manage your projects. All right, and to upload your work onto GitHub. We refer to these commands as yes. Hello. Sorry, I just saw that message because the window was behind my OBS. Yeah. So if you can hear me okay, microphone and audio, if you can let me know in the chat, that would be awesome. Because I made slight changes. Alright, so in this lesson we will cover how to create a repository on GitHub, how to get files to and from GitHub. That's what I want to remind myself of. I did that recently actually, but see how it looks like again. How to take snapshots of your code. Okay, all clear, awesome, thank you. Alright, so before you start, GitHub recently updated the way it names the default branch. This means you need to make sure you are using a recent version of Git 2.280 later. I don't remember which version I am on, but I am pretty sure it's one of the latest ones. Let's find out actually. So is it version 2.37? Yeah, so we are safe here. If you haven't already, set your local default Git branch to main. You can do so by running. There's a slight catch here because I have already been using a main branch, so I don't remember if that will change something. Yeah. Let's see. I'll probably need to sign into my GitHub, won't I? Okay. You should have already created a GitHub account. Okay. Alright, yeah, let's go through it actually from start. So let's create a new repository. Let's log in. I'll need my phone for that. because of double authentication. Let me see where it is. Okay. So let me just quickly log in here. And GitHub, sign in. Username or email address. And the password. So for this part, I'm gonna lock out the screen, just in case. So let me just grab my password for GitHub. Where's Git? Searching for it. There we go. Alright, authentication code. So I'm just grabbing that. Alright. And we're back. So I signed in, and I hope you didn't see that. Yeah. Actually, let me remove something quickly because I don't want you to see my password. You can do all sorts of things with it. All right. I just cleared my clipboard. So I'm gonna create a new repository like they say, but I'm gonna move this to the side. Oh, how odd. I cannot move it to the right. That's strange. That's okay. So we were here, and that's a bit big. Okay. So we have an account. Create a new repository by clicking the button shown in the screenshot below. So a new repository. The Odin project 2. Description. Test. Oh yeah, that can be public. It's fine. What's next? Give your repository the name git-test. Oh, git underscore test. I'll just put 2 at the end because I already created one from before. Click the green button at the bottom of the page. All right. Okay, so what's next? Oh, I clicked on an image. I didn't want that. To get ready to copy, clone this repository onto your local machine, click the green code button. Green code button. I do not see a green code button. It's simply not there. But we have an image that shows us the SSH. Select the SSH option and copy the line below it. You must click the SSH option to get the correct URL. Okay, so we copied that. Command line now. Okay, so we need to pull up a file manager, which is right here. And I want to keep all my stuff on my desktop, but the way they do it is actually via command line terminal. So we will do that too. First I need to check where I am. So I am in the root directory. So let's see the desktop. Is it case sensitive? Yes, it's case sensitive, meaning desktop and desktop are two different things. Okay, that's fine. So make directory repos repositories. Cool. Now it's time to clone your repository from GitHub onto your computer with git clone, followed by the URL you copied. Okay. Ah. Now here's the catch. Okay, so we cannot continue because recently GitHub, well not recently, I think it was last year, they changed the way you authenticate. So we cannot move on. Oh, this, come on, just grab the thing. Make this bigger. All right. Let's copy this. And let's research what is wrong with it. And that's my Azure stuff I was looking at earlier. And Stack Overflow. Okay, let's take a look at this file that they're talking about. No such file. It could be that I'm in the wrong directory, which is okay. Okay, so we are entering the SSH territory here with authentication, getting secure keys and stuff like that. And those keys you're not supposed to show. So I'm gonna skip this part. Okay. Because I don't want you to see my keys. My secure keys for my projects and everything. You can do all sorts of stuff with that. Alright. Let's just pretend we did this part. Again, my main point is really just a quick refresh of Git. I mean, I probably already showed you too much. It doesn't matter because it's on a live stream, but still. So when it comes to this example, for example, touch hello.txt. So here we actually created a file hello.txt. So let me show you. File manager. So here's the desktop, repos, and that's the hello text, right? And we can do the same with touch index.html. Right, I'm not sure, I think maybe you can even like oh no, that's funny. Yeah, delete them. But here we have index.html. So I could write something like hello world, right? And that may display actually. I'll save it. Let's see what happens. Yes. Yeah, so it renders hello world in the file. That's pretty cool. So git status. So when it comes to my notes, I am after the commands really, because I remember this stuff right here. Alright, so this is where we start. Yeah. Use the workflow. So let's try that git status. Theory, git repository. Oh, okay, I see. So we want to be able to get a commands because we need to connect to it. I'll do that off the stream for next time, maybe. But here's the breakdown. Right, so here it says type git status in your terminal, which is this box right here. In the output, notice that your hello world.txt file is shown in red, which means that this file is not staged. And there are different stages in Git, which I'm sure they'll go through. Type git add hello world. This command adds your hello world file to the staging area in Git. And the staging area is part of two-step process for making a commit in Git. Think of the staging area as a waiting room. So we make some changes to the file. We then add the file to the waiting room. Weird changes, so they are waiting there until we commit them. And when it's in the staging area, it will be green, like in this example. Okay. Type git commit -m. Okay, so -m is the message. So we commit the file with the message. And we then type git status once more. And then it says nothing to commit, working tree clean. Okay. The message, your branch is ahead of origin -main by one commit, just means that you now have newer snapshots than what is on your remote repository. You'll be uploading your snapshots further down in this lesson. Okay. Type git log and look at the output. You should see an entry for your hello world commit. Well, I'm just gonna get some water. I am not used to this much talking. All right. You will also see details on the author who made the commit and the date and time of when the commit was made. So, in other words, you leave in a trace. If your terminal is stuck in a screen with and at the bottom, just press Q to escape. You can configure settings for this later, but don't worry about it too much for now. See. Right. So I have my Visual Studio here. So, and I'll do just that. Open a folder. Desktop repositories. Open. Yes, trust all files. We have index HTML. I'll just fill this up. Made it a little bit bigger. Like so. Hopefully you can see it. I'll just leave that as document, it's fine. Right, back to the basics. Actually, I can minimize that. So essentially we're working with git add, git commit, so we commit that, and then the last command is actually push, git push or git push origin main. So I'm just gonna make a note of that. Push your work to GitHub. So git push origin main. All right. Oh, there we go. Yes, essentially this is what we get. So what steps are those? Switching remote URL from HTTPS to let me try this once quickly, see if that works. And if not, I'll do it later. Right, of course. This is SSH. So we copy that. Okay. Git remote. Right. Git remote set dash URL. Yeah, that's not gonna work because I need to play about with special tokens, which I cannot show on the stream. So I'm just gonna skip this part, but I have done it before. All right. Yes. Okay. You may not feel completely comfortable with Git at this point, which is normal. It's a skill that you'll get more comfortable with as you use it. Yes, that is true. The main thing to take away from this lesson is the basic workflow. Alright, which is create a file, make some changes, commit those changes, and push. And that goes to a GitHub repository. Alright. Next, so that was Git basics, which is fine. So with HTML we've done this. CSS as well, Flexbox, yes. Basics, rock, paper, scissors. Done this one actually, once. I did not do this, and I didn't do calculator. But the main thing I wanted actually to look at is this right here, the back end. Oh, I think I just opened it twice. All right. So with that, I'm gonna make this a little bit smaller. I don't even need this at this point. All right. Let's have a read through. Introduction. The front end denotes the interface that a web user interacts with, what they see and hear when using the web. The three languages of the front end are HTML, CSS, and JavaScript. The back end denotes all that goes on behind the scenes on web servers to make the user experience possible. In contrast to front-end development, you can run pretty much any language you want to on your server, since it doesn't rely on your users' browser understanding what's going on. all the browser cares about is whether you've sent it properly formatted HTML, CSS, and JavaScript files, and other assets like images. So that has led to a whole lot of different choices for backend languages. As long as it can take in an HTTP request and spit out some HTML, you can probably put it on a server somehow. That said, some languages are more popular and practical than others. If you're running your own server, you have a ton of flexibility, but plenty of headaches. If you're using the cloud, which we will be doing later, you may be restricted to those languages that your cloud provider has installed on their platform. It doesn't do you much good if the service you are borrowing from can't understand your code. Agreed. Yeah. Some of the most popular server-side languages are PHP, C#, Ruby, Python, and Java. Not to be confused with JavaScript. So actually I want to make a note of that. It's popular server-side languages. So we have PHP, C#. You can also create cool interfaces with C# in Visual Studio, which I have done on my channel before, but now I have zero knowledge of C# because I have not used it in many months, probably over a year actually. Python and Java. Not to be confused with JavaScript. That's what I was confused about. Java and JavaScript are two different things. Okay. Just as I can say, which way to the nearest pub? In Swedish, French, Italian, English, and Bad English. So too can all of those languages perform almost exactly the same functions, just using different syntax. As we covered back in the installation section, the front-end languages live in the browser, so you don't need to install it. For the reasons listed above, the backend languages do require you to install them on your computer in order to get them running. Node.js has already been installed as it is required in the JavaScript section of Foundations. Ruby and Rails are installed in their own respective sections as they aren't required until then. That looks interesting. I'm gonna skip those two. I don't need them. Because I am already familiar with that. But this looks interesting. Let's have a read through. Backend Web Architecture, Code Academy team. This article provides an overview of servers, databases, routing, and anything else that happens between when a client makes a request and receives a response. Software engineers seem to always be discussing the front end and the back end of their apps. But what exactly does this mean? The front end is the code that is executed on the client side, meaning like laptops and stuff. Laptops, mobile devices, PCs, anything really that a person can hold in their hand or look at, pretty much. Nowadays, that would probably include one of those smart TVs as well, as long as they can do the web browsing. So that would include those as well. Alright, so the client side. This code, typically HTML, CSS, and JS, runs in the user's browser and creates the interface. Yes, and we did create that a few times. Wait, interface? Yes, we did. And product landing page. The backend is the code that runs on the server that receives a request from the client and contains the logic to send the appropriate data back to the client. The backend also includes the database, which will persistently store all of the data for the application. This article focuses on the hardware and software on the server side that make this possible. Review HTTP and REST if you want to refresh your memory on these topics. These are the main conventions that provide structure to the request-response cycle between clients and servers. I will check out REST APIs, I think it was. Actually, let's check HTTP as well. Understand the basics of how your web browser communicates with the internet. This page is generated by a web of HTML, CSS, and JS, sent to you by Code Academy via the internet. The internet is made up of a bunch of resources hosted on different servers. Okay. So what is HTTP? HTTP stands for Hypertext Transfer Protocol and is used to structure requests and responses over the internet. HTTP requires data to be transferred from one point to another over the network. The transfer of resources happens using TCP, Transmission Control Protocol. So hold on, let's slow down. HTTP requires data to be transferred from one point to another over the network. Okay. And it is used to structure requests and responses over the internet. The transfer of resources happens using TCP. So this structures it, and TCP, the transfer resources happen, and looks like TCP, sends them over. TCP manages the channels between your browser and the server, and TCP manages many types of internet connections in which one computer device also sends something to another. HTTP is the command language that devices on both sides of the connection must follow in order to communicate. Okay, so this helps communicate. HTTP is a common language that two devices use, and TCP manages many types of internet connections. So So TCP manages connections where the data is getting sent across from one to the other side, or vice versa. Yeah. When you type an address such as codedisciple into your browser, you are commanded to open the TCP channel to the server that responds to the URL. Uniform Resource Locator, URL, which you can read more about on Wikipedia. That's a nice resource. I like this. I can use it as a good reminder. So I'm gonna add it to my notepad, to my Word document now. Okay. All right, cool. Now, REST. That's what I'm more curious about. Oh, we have a nice picture too. Learn about how to design web services using the REST paradigm. Whoa. What is REST API? So we can see we have the database, which stores / contains data. We have a web server. We have API. And your website application. And it goes in like a loop. So it goes forward, backwards, okay. Alright, so what does this mean? Representational state transfer. REST, or representational state transfer, is an architectural style for providing standards between computer systems on the web, making it easier for systems to communicate with each other. REST-compliant systems, often called RESTful systems, are characterized by how they are stateless and separate the concerns of client and server. We will go into what these terms mean and why they're beneficial, and why they are beneficial characteristics for services on the web. Separation of client and server. In the REST architectural style, the implementation of the client and the implementation of the server can be done independently without each knowing about the other. This means that the code on the client side can be changed at any time without affecting the operation of the server. And the code on the server side can be changed without affecting the operation of the client. Is that where cookies come in? And like when they and the content gets downloaded and held in some kind of memory, because when you refresh it sometimes you have to clear cookies to pull new content and stuff like that. I wonder. Yeah, that must be a reason. That may be why. As long as each side knows what format of messages to send to the other, they can be kept modular and separate. Separating the user interface concerns the data storage concerns. We improve the flexibility of the interface across platforms and improve scalability by simplifying the server components. Additionally, the separation allows each component the ability to evolve independently. By using a REST interface, different clients hit the same REST endpoints, perform the same actions, and receive the same responses. Statelessness. Systems that follow the REST paradigm are stateless, meaning that the server does not need to know anything about what state the client is in, and vice versa. In this way, both the server and the client can understand any message received, even without seeing previous messages. This constraint of statelessness is enforced through the use of resources rather than commands. Resources are the nouns of the web. They describe any object, document, or thing that you may need to store or send to other services. Explore how the communication between the client and server actually happens when we are implementing a RESTful interface. Communication between client and server. In the REST architecture, clients send requests to retrieve or modify resources, and servers and responses to these requests. Let's take a look at the standard ways to make requests and send responses. Making requests. So REST requires that a client make a request to the server in order to retrieve or modify data on the server. Okay. I'm gonna get my Galaxy chocolate. Get that boost of energy, because I'm doing a lot of reading right now. Alright, so A request generally consists of an HTTP verb, which defines what kind of operation to perform. A header, which allows the client to pass along information about the request. A header. You mean like a header inside HTML? Maybe. Possibly. A path to a resource. An optional message body containing data. It looks like HTML, yes. Perhaps. Oh no, it's not. No, I am mistaken. It's something else here now that I noticed. HTTP verbs. There are 4 basic HTTP verbs we use in requests to interact with resources in a REST system. Get, retrieve a specific resource by ID, order a collection of resources. Post, create a new resource. Put, update, and delete. Remove specific resource. What is CRUD? Okay. Headers and accept parameters. In the header of the request, client sends type. Okay. Sends a type of content that is able to receive from the server. This is called the accept field, and it ensures that the server does not send data that cannot be understood or processed by the client. The options for type of content are MIME types or multi-purpose internet mail extensions, which you can read more about in the MD and web docs. MIME types used to specify the content types in the example consist of type and a subtype. They are separated by a slash. For example, a text file containing HTML would be specified with the type text/HTML. If this text file contained CSS instead, it would be specified as text/CSS. Remember that keyword from CSS? So for example, if we create styles.css, right? And we link rel style sheet. Link rel and type text/CSS. Yeah. That's what they mean, I think. So we specify what kind of file, what kind of type of file this is. So it's a text/CSS. All right. Those are the paths and it's interesting. So get articles. So that's what the request looks like. And that's the return code. That's the code for okay. I think 404. Either 400 or 404 is not okay, meaning it failed to fetch the content. Okay. 404, I think. Yeah. All right. So I think that's enough knowledge for now. Let's read this. Clients, backend, execute to display a website to the end user. There are many kinds of clients: mobile application, server, web-enabled smart appliance. Yeah. Backend, server, app, database. A server is simply a computer that listens for incoming requests. Though there are machines made and optimized for this particular purpose, any computer that is connected to a network can act as a server. Yep, that's true. What are the core functions of the app? The server runs an app that contains logic about how to respond to various requests based on the HTTP verb and the uniform resource identifier. The pair of an HTTP verb and a URI is called a route, and matching them based on a request is called routing. Uniform resource identifier. Okay, what kind of responses can a server send? The data that the server sends back can come in different forms. A server HTML file, send data as a JSON, status code. Yeah, so photo 4, like I mentioned slightly earlier, not found because it doesn't exist. Maybe down or something, I don't know. What is a database and why do we need to use them? Databases are commonly used on the back end of web applications. These databases provide an interface to save data in a persistent way to memory. Storing the data in a database both reduces the load on the main memory of the server CPU and allows the data to be retrieved if the server crashes or loses power. Many requests sent to the server might require database query. A client might request information that is stored in the database, or a client might submit data with the request to be added to the database. What is a web API, really? An API is a collection of clearly defined methods of communication between different software components. More specifically, a web API is the interface created by the backend, a collection of endpoints and the resources these endpoints expose. Let me read that again because that went over my head. More specifically, web API is the interface, so like a UI. Well, no, not really. It is the interface created by the backend. Okay. The collection of endpoints and the resources these endpoints expose. Web API is defined by the types of requests that it can handle, which is determined by the routes that it defines and the types of responses that the clients can expect to receive after hitting those routes. On a web API, can be used to provide data from different front ends. Since a web API can provide data without really specifying how the data is viewed. Multiple different HTML pages or mobile applications can be created to view data from the web API. Other principles of the request-response cycle. The server typically cannot initiate responses without requests. Every request needs a response, even if it's just a photo for status code indicating that the content was not found. Otherwise, your client will be left hanging, indefinitely waiting. Yeah. The server should not send more than one response per request. This will throw errors in your code. Ping out a request. Let's make all of this a bit more concrete. Hold on 1 second, because I need to do something here. But first I need to... Yeah. 1 second, this brightness is killing me, man. Who designed this thing? Main. Can I like edit the code here? Main, where are you? Main. Class. Color. Yeah. Because my eyes were killing me, man. Damn. That's better for me. This is why I love HTML. I can just edit, make it how I want it. Alright, let's take a look at this concrete stuff. Make all of this concrete by following an example of the main steps that happen when a client makes a request to the server. First one. Alice is shopping on our super cool shop. She clicks on a picture of a cover for her smartphone. And that click event makes a get request to... Okay, so that's the case. Remember, get describes the kind of request. Get the data, not changing anything. Specify that the client is looking for more information about the product, and the product has an ID of 66432. Super Cool Shop has a huge number of products and many different categories for filtering through them, so the actual URI would be more complicated than this. But this is the general principle for how request and resource identifiers work. Alice's request travels across the internet to one of Super Cool Shop servers. This is one of the slower steps in the process. Because the request cannot go faster than the speed of light. That's quite funny. This is one of the slower steps because the request cannot go faster than the speed of light. It's like saying the speed of light is slow. And it might have a long distance to travel. Let me check something. The world. Light travels at a constant finite speed of 18600 miles a second. You could lap the entire world 7.5 times in a second. So, if Alice cannot wait for like a half a second to get her request, then she's too demanding. Oh, that's crazy stuff. Alright. And they will direct users to the server that is closest to them. Alright, but hold on. Major websites with users all over the world will have many different servers, and they will direct users to the server that is closest to them. Right? The server which is actively listening for requests from all users receives Alice's request. So, event listeners that match this request, HTTP verb get and the URI are triggered. The code that runs on the server. I like this stuff. I'm gonna copy this into my notes. Yeah, but sometimes internet is slow. Sometimes there may be caps. So for example, caps I mean by there's a limit posed by the internet service provider that could restrict the speed, or some other mobile network provider maybe. We can also get slowdowns of the internet by different types of internet cables. So for example, instead of fiber, maybe there's like an old Cat5 or DSL line that is very slow. So that could be also a way. And next step. In processing the request, the server code makes a database query to get more information about the smartphone case. The database contains all of the other information that Alice wants to know about the smartphone case. Name of the product, the price, reviews, and a string that will provide a path to the image of the product. Alright, so database stores all this information. The database query is executed, and the database sends the requested data back to the server. It's worth noting that database queries are one of the slower steps in this process. Yes, reading and writing from static memory is fairly slow, and the database might be on a different machine than the original server. This query itself might have to go across the internet. Now that makes sense. The server receives the data that it needs from the database, and it is now ready to construct and send its response back to the client. This response body has all of the information needed by the browser to show Alice more details, price, reviews, size, etc. about the phone case she is interested in. The response header will contain an HTTP status code 200 to indicate that the request has succeeded. The response travels across the internet back to the computer, Alice's computer. Alice's browser receives the response and uses that information to create and render the view that Alice ultimately sees. Alright, So that was a very nice breakdown, in my opinion, of what is actually happening in the entire process. How many parts does the backend consist of? I don't understand the question. Oh yeah, client's backend server, core functions. Yeah. Where does the backend store its data? In a database. All right. Introduction to frameworks. So I will do that as well. But first, let me just quickly check how much memory I have. Where is the task manager? How much memory? 2.9 out of 6. 51%. Okay. I'm gonna close some stuff. This is Azure stuff. Yeah, I'm on a VMN. I don't want it to crash. So I'm just gonna lower the memory a little bit. And frameworks. Let's go. And let's change this one as well. No. What? Yeah, that was weird. All right. Frameworks. Introduction to frameworks. That's gonna be interesting. So what are frameworks? Frameworks, I think, are tools to make our life easier. All right, let's see. I'm gonna start here. Introduction to frameworks. All right, let's have a read through. We're doing a lot of reading today, actually. Programmers, the best of whom are pretty lazy folk, in a good way, got tired of having to write the same code over and over and over again just to cover the basic tasks that they wanted their applications to perform. So they batched that recycled code together and called it a framework. In addition to preventing repetition, frameworks provide great organization. They tend to force you to organize your files and code in a way that keeps it highly modular and really clean. When you start a new app with any framework, you are given dozens of folders already organized in a hierarchy, which makes sense and follows good practice such as Model View Controller, MVC, separation principles. It's not quite color by numbers for code, but it certainly keeps things ordered. There are often several different popular frameworks for a given language. They can have exciting names like Ember, Meteor, Django, Rails, Grok, etc. Wikipedia has a comprehensive comparison of frameworks. That should give you an appreciation of the number of them. General. ASP, C++, Cold Fusion Markup Language, Elixir, Haskell, Java, JavaScript, Perl, Python, Ruby, Scala. Project. Express.js, Meteor, Sails. I never used any frameworks before. Okay. Where was I? Oh, yes. A final thing to notice about licensing. Frameworks are typically, though not always, open source, and their license allows you to use them, modify them, make money off them, sell products with them, etc., all without owing any fees to their original creators. You may not think too much about that as you lively code away using other people's frameworks, but it is a very important distinction between open source and commercially produced / sold software. We'll get more into open source software OSS in later units. Okay. So we learned what frameworks are. They're a tool used to make your life easier. Ensure that you don't repeat the same code for common tasks pretty much, and help you build stuff. Alright. What's next? So, now that you've had a healthy taste of the basics of web dev, it's time to choose what specialty path you would like to take. This is a big decision. Alright. That was quite a journey. Take a second to reflect on what you just learned. For these 3 different languages, you should be able to create a basic web page and make it do some basic things with JavaScript. Okay, with what you know already, you can start putting together some basic websites, but we're to help you get a lot further than that. We want to bring you to the point where you can confidently build a full-featured, scalable web application, either on your own or working as a developer in a top-tier tech company. Now that is the dream, isn't it? That's the dream right there. You've come a long way up the learning curve, but there's so much more cool stuff that you will learn to do. Either Ruby on Rails, or JavaScript with Node/Express. Become a well-rounded developer, but sticking one could make you more of an expert in a particular language. Okay. The important thing is to not switch halfway through. Not switch halfway though. This will only set you back. Alright. Learning how to program is much more than just learning a language. It's about learning how to research and solve difficult problems, building an engineering mindset, working on complex problems and code bases, communicating effectively with other developers, and much more. Luckily, all these skills are transferable to other languages and domains of software, and because most languages are similar in concept and structure, moving into a different language will be much easier than learning your first. Arguments about learning languages used in your area may sound convincing. Okay, but because a good developer can trust this goes easily, what you learn isn't going to massively change outcomes of getting a job. Though, if you cannot shake that fear, do whatever you need. To help you make a decision, here are some perks of each tech. Ruby and Ruby on Rails. Opinionated. You will learn things the Ruby way, which can help you write clean code. Elegant. Rapid development. Single paradigm. Node and Express. Very fast. Verbose. There is no magic involved with these texts. You will have to understand everything to make sense of it. Helps you get closer to how the computer is actually reading your code. Same language on both front end and back end. Keeping the language consistent can help with writing consistent code across your entire application. And there's a little spinner that you can use to decide. Alright. I'll just check something real quick. Alright, I think I have picked my path. I will go with not Ruby and Ruby on Rails, but JavaScript, Node, and Express. Alright. Yeah, with that said, with that said, I'll make a stop to the live stream here. I think there's a limit on how long I can live stream as well. Oh, I probably said it myself. That's okay anyway. Yeah, so I have picked my path, but I will not be getting into it today. I'll start that another day. With that said, hope you enjoyed the live stream, and thank you for watching.